Welcome to our deep dive into one of the most enduring debates in consumer technology, iPhone versus Android, specifically focusing on raw speed and performance. For years, users on both sides of this divide have championed their preferred operating system, often citing speed as a primary differentiator. Is one inherently faster than the other, or is it a more nuanced comparison? Today, we're not just looking at subjective user experiences, we're breaking down the technical underpinnings, examining everything from silicon to software optimization to truly understand what drives performance in modern smartphones. This isn't just about milliseconds, it's about architectural philosophies, ecosystem design, and how these factors coalesce to deliver the user experience you encounter daily. Join us as we explore the intricate world of smartphone speed tests and discover the truth behind the headlines. Before we pit these giants against each other, it's crucial to establish what speed truly means in the context of a smartphone. It's far more complex than a simple stopwatch measurement. We're talking about a multifaceted concept encompassing boot-up times, the instantaneous launch of applications, seamless multitasking capabilities without slowdowns, smooth navigation through user interfaces, and the efficiency of rendering complex graphics in demanding games. Additionally, factors like web browsing responsiveness, file transfer speeds, and even the speed of AI/ML computations for features like camera processing contribute to the overall perception of a device's alacrity. Each of these components is influenced by a distinct combination of hardware capabilities and software efficiencies, making a holistic definition essential for a fair comparison. At the heart of every smartphone's speed lies its System on a Chip, or SoC. Apple's A-series chips, such as the A17 Pro in the latest iPhones, are renowned for their industry-leading single-core and multi-core performance, often outpacing competitors in synthetic benchmarks. These chips are custom-designed, allowing for unparalleled integration with iOS. On the Android side, we see a diverse landscape, primarily dominated by Qualcomm's Snapdragon series, but also featuring Google's Tensor chips and MediaTek's Dimensity offerings. While these chips are incredibly powerful, they must cater to a wider array of devices and software configurations. RAM also plays a critical role, though iOS and Android handle memory management differently. iOS typically requires less RAM for comparable performance due to its efficient, tightly integrated design, while Android, managing a more open and fragmented ecosystem, often benefits from higher RAM counts, such as 12 GB or even 16 GB, to maintain smooth multitasking across various apps. Beyond the raw power of the silicon, the operating system itself is a massive determinant of perceived speed. Apple's iOS benefits immensely from being a closed-source, tightly controlled ecosystem. This means Apple optimizes its software specifically for a handful of hardware configurations, allowing for highly efficient resource management, predictable performance, and minimal overhead. For instance, animations and transitions are meticulously crafted to feel instant and fluid. Android, in contrast, is an open-source platform, which, while offering incredible flexibility and customization, introduces fragmentation. Different manufacturers create custom skins and modifications, such as Samsung's One UI or Google's Pixel UI, on top of stock Android. This diversity, combined with the need to support a vast array of hardware specifications, often means that optimizations are more generalized. However, significant advancements in Android's runtime, like the shift from Dalvik to ART, Android Runtime, have dramatically improved application execution speed and system responsiveness over the years, making the gap considerably smaller than it once was. To objectively compare performance, we often turn to benchmarking tools. These applications are designed to stress various components of a smartphone and provide quantifiable scores. Popular examples include Geekbench, which measures CPU performance, single-core and multi-core, Antutu, a comprehensive benchmark that evaluates CPU, GPU, memory, and UX, and 3D Mark, specifically tailored for graphical performance and gaming capabilities. While these tools offer valuable insights and allow for direct comparisons across devices, they come with significant limitations. Benchmarks are synthetic tests. they don't always perfectly replicate real-world usage scenarios. A phone that scores exceptionally high in a benchmark might not always feel proportionally faster in daily tasks, and vice versa. Furthermore, manufacturers have sometimes been accused of cheating benchmarks by optimizing their devices to perform exceptionally well, specifically when a benchmark app is detected, leading to inflated scores that don't reflect typical performance. Therefore, while useful, benchmark scores should be interpreted with a critical eye as just one piece of the performance puzzle. Moving beyond synthetic benchmarks, real-world usage scenarios provide a more tangible understanding of speed. One of the most frequently performed actions is launching applications. In general, flagship iPhones tend to open apps slightly faster than even top-tier Android phones in a cold start scenario, where the app isn't already cached in memory. This is often attributed to Apple's superior optimization between hardware and software, allowing for quicker loading of assets and execution of code. However, the gap is often negligible, sometimes only a few milliseconds, and can vary depending on the specific app's optimization for each platform. When it comes to multitasking, both platforms excel, but with different approaches. iOS typically freezes background apps more aggressively, ensuring that foreground performance remains pristine. Android, with its more open approach, often keeps more apps live in the background, which can lead to faster switching between recently used applications, especially on devices with ample RAM. The perception of speed in multitasking heavily relies on how many apps you typically keep open and how quickly you need to switch between them. For gamers, smartphone speed translates directly into frame rates, graphical fidelity, and a smooth, immersive experience. Here, both platforms offer incredible capabilities, but often through different technical approaches. Apple's A-series GPUs are consistently at the forefront of mobile graphics, delivering exceptional raw performance and power efficiency. With Metal API, Apple provides developers with a low-level access to the GPU, enabling highly optimized and visually stunning games that run seamlessly on iPhones. On the Android side, devices leverage powerful GPUs from Qualcomm, Adreno, ARM, and Google Titan. While these GPUs are potent, the fragmentation of the Android ecosystem means developers must optimize for a wider range of hardware and software combinations. However, advancements in Vulkan API and OpenGL have significantly improved Android's graphical prowess. Flagship Android phones are perfectly capable of running the most demanding games at high settings, often matching or even surpassing iPhone performance in specific titles, especially those optimized for high refresh rates like 120Hz displays. Thermal management also becomes critical during extended gaming sessions. A phone that manages heat effectively can maintain peak performance longer. A crucial yet often overlooked aspect of smartphone speed is how well a device maintains its performance over time. It's one thing to be fast out of the box, but another to remain snappy after 2 or 3 years of use. Software updates play a significant role here. Apple is known for providing many years of software support, often 5 to 7 years, ensuring older iPhones receive crucial performance enhancements and security patches. While some updates can occasionally introduce new features that strain older hardware, Apple generally aims to optimize performance. Android's update landscape is more varied due to the fragmentation mentioned earlier. Google's Pixel phones receive timely and long-term updates, typically 5 to 7 years for security and OS, while other Android manufacturers vary wildly, often providing 2 to 4 years of major OS updates. Beyond software, battery health significantly impacts performance. A degraded battery can lead to CPU throttling to prevent unexpected shutdowns. Storage degradation, as flash memory wears out, can also slow down read/write speeds, affecting overall system responsiveness. Both platforms face these physical limitations, but the software approach to mitigating them differs, with iOS historically being more proactive in managing battery-related performance impacts. Perceived speed is not just about the device itself. It's also heavily influenced by the surrounding ecosystem and how seamlessly different devices and services integrate. Apple's ecosystem is a masterclass in tight integration. Features like handoff, AirDrop, and iCloud Sync Ensure that your iPhone, iPad, Mac, and Apple Watch work together flawlessly, creating a highly efficient and fast-feeling workflow. The consistency across devices means less friction and quicker transitions between tasks, even if the raw processing speed isn't always superior. Android, being a more open platform, offers a diverse range of interconnected services, often centered around Google's pervasive suite of applications like Google Drive, Google Photos, and Chrome, which sync across various Android phones, tablets, and even Chrome OS devices. While this ecosystem is incredibly powerful and flexible, the sheer variety of manufacturers and software layers can sometimes lead to inconsistencies or minor delays in cross-device functionality compared to Apple's perfectly synchronized offerings. Ultimately, the speed of your workflow is dictated not just by your phone, but by how well it communicates with your other digital tools. After meticulously examining hardware, software, benchmarks, real-world scenarios, long-term performance, and ecosystem integration, what's the definitive answer to which is faster, iPhone or Android? The truth is, it's not a simple binary. In raw synthetic CPU and GPU benchmarks, Apple's A-series chips often take the lead. For app cold launch speeds, iPhones frequently hold a slight edge. However, in multitasking with many apps, high-end Android phones with abundant RAM can feel equally, if not more, fluid. Gaming performance is neck and neck, with both platforms offering exceptional experiences. Ultimately, speed is often subjective and heavily dependent on your specific usage patterns and preferences. The overall user experience encompasses much more than just milliseconds. It includes camera performance, battery life, display quality, customization options, and the total cost of ownership. The competition between iPhone and Android continues to drive innovation, benefiting all consumers with increasingly powerful and responsive devices. So, while benchmarks offer a glimpse, the fastest phone is truly the one that best suits your individual needs and integrates most seamlessly into your digital life.